Today I'm going to talk about the mean and variance of a Poisson distribution. Here is a brief statement, just what they are. If x belongs to a Poisson distribution with mean lambda, then we can show that the expected mean is lambda and the expected variance is also lambda. Unfortunately, this is a little bit too difficult to prove at this stage. What does that really mean? Well, that means that if we take x as a random variable with a Poisson distribution with mean lambda, and if a very large number of values of x are recorded, x1, x2, x3, up to a very large number, then we would expect the mean of all these numbers, x1, x2, x3, to be lambda, and the variance of all these numbers, x1, x2, x3, also would be lambda. Well, let's do just an easy little example on this. In producing rolls of cloth, we have on average 4 faults in every 10 meters of cloth. How can we find the probability of fewer than 3 faults in a 6-meter length? Well, this is similar to the ones you've been doing. We are looking here at 6 meters. We know that the mean lambda is 4 in 10 meters. And so if we want the mean in 6 meters, we're going to have to do the mean is lambda. It's 4 in 10 meters, so it's 4 over 10 in 1 meter. 4 over 10 times 6, which is 2.4 in 6 meters. Now we want x is the number of faults in a 6-meter length. X will be Poisson 2.4, a vital part of your explanation. Fewer than 3 is probability that x is 0 or 1 or 2, and we can just add those together. Probability that x is 0, if we remember the formula, it's e to the minus lambda. X is 1 is lambda, which is 2.4 e to the minus lambda divided by 1 factorial plus lambda squared, 2.4 squared, times e to the minus lambda divided by 2 factorial. Press the buttons and we get 0.570, 3 significant figures. Don't give 0.57. 0.57 is just 2 significant figures. You should give 3. We're now asked to find the variance of the number of faults in a 15-meter length. Well, remember that we had 4 faults on average in 10 meters. And so lambda is going to be equal to 4 over 10 times, let's make that 10 rather nicer if we can, 4 over 10 in 1 meter times 15, which is 6 faults in 15 meters. So the expected value of lambda, or the expected value of x, I should say, is lambda, which is 6. And the expected variance is also lambda, which is 6.